Now let us see how to delete an element from our linked list. So I will write a function delete element where I will take the linked list, then the element which I have to delete. Now let us assign a temp to sll.head. So temp will point to the head. We will check if the head is our element. If temp.data is our element, if we found our element at the head position, then ssl.head equals to temp.next, which means we are now pointing our head to the next pointer. That is, if we found that our head is our element, then we are just pointing our head to temp.next. Now our head will be passing to B, and that is how we will do that if our element is found at head. Now we will make our temp none, that is tmp equals to none, and else if it is not found at head, then we have to use while loop. While temp is not none, we have to traverse through linked list. If temp.data is the element, if we found the element in between, then what will we do? We will break the loop. We will write here break. Now to store the position of the current pointer, I will create a before pointer which will be pointing to the temp, and then we have to iterate through the loop. Therefore we will write temp equals to temp.next. So this will help me to go to the next element, and the before pointer will help me to keep the track of previous element. As we have to delete that element, so we will point the before element to the next of the next element. So before dot next equals to temp dot next. So how this will happen? If I pass let's say 3, so I want to delete C. So I have pointed our BEF to B. So I will write here BEF. So BEF is B, and our temporary variable will be pointing to C. So I will write TMP over the C. Now what I am doing is I am pointing before dot next is the temp dot next, which means I am pointing before to the D. So it will create a arrow which will be like this. It will be directly pointing to the D. Let us try the different arrow. So B will be directly pointing to the D. So B is directly pointing to D, so C will be automatically discarded. So this is what we are doing in the last stage. So let us try and pass the element. I will pass our linked list. Let us say I want to delete 1000, and let us print the linked list again and run the code. So 1000 from our linked list has been deleted. So if I comment this code out and run the code, I will get 1000. And if I delete that, let us delete some more element. I will copy paste it. Let us delete the 5 and let's say 99 and run the code. So 5, 99 and 1000 has been removed from our linked list. So this is how we can implement the delete element function. Now let us try and implement the delete element function for doubly linked list. So delete element, I will copy this from here. Let us paste our code here. Now we are traversing through the list and I am pointing before dot next to the temp dot next. Now temp dot next dot previous should be pointing to before dot next. So just this much of modification is needed in order to make this work for doubly linked list. So let us try and delete an element from doubly linked list. So delete element, I will pass DLL. Let us make this SLL to TLL. So TLL. So here. So I will pass doubly linked list and the element I want to delete. Let us say I want to delete 1000 and let us run the code. Let us print the linked list again. So 1000 has been deleted. Let us try and delete some more elements. Let's say 88 and the 3 and run the code. So 88, 3 and 1000 has been removed. So this is how we can implement the delete element function for the single linked list and doubly linked list. So thanks for watching this video, and if you have any doubt you can ask me. So thanks for watching and I will see you in the next one.